Welcome inside one of the world's most advanced fiber optic cable factories, where ultra-pure glass is transformed into the backbone of global communication. Every fiber optic cable begins with one essential ingredient, ultra-pure quartz sand, the primary source of high-quality silica glass. The quartz is refined through advanced purification processes, removing microscopic impurities that could weaken optical performance.
Using chemical vapor deposition, ultra-pure silica is deposited layer by layer to form the foundation of future optical fibers.
The finished glass preform contains the precise internal structure that will guide light across thousands of kilometers.
Every preform is carefully inspected to ensure perfect optical clarity. Before fiber drawing begins,
the glass preform is carefully positioned inside a towering drawing system. This system will produce kilometers of optical fiber. Extreme temperatures soften the glass until it can be drawn into an incredibly thin optical fiber. The softened glass is drawn into an optical fiber, thinner than a human hair, while laser sensors constantly monitor the fiber's diameter, ensuring every meter meets exact manufacturing specifications. A protective polymer coating is instantly applied. This shields the delicate glass fiber from damage. Powerful ultraviolet light hardens the protective coating in milliseconds, creating a durable outer layer. The coated fiber is carefully cooled and stabilized before continuing to the next stage of production. Each fiber undergoes continuous strength testing to verify it can withstand the demanding conditions of real-world installation.
Finally, the finished optical fiber is wound onto precision reels. It is now ready for the next stage of cable manufacturing.
Each optical fiber receives a unique color coating, allowing technicians to identify and organize hundreds of fibers with ease.
a durable secondary buffer protects each delicate fiber from moisture, abrasion, and mechanical stress during installation.
The protective buffer is rapidly cured and cooled, creating a tough yet flexible layer around every optical fiber. For high-capacity networks, multiple fibers are bonded into ribbons, increasing installation speed and transmission density. Loose tubes provide extra protection, allowing optical fibers to move slightly without experiencing damaging mechanical strain. A special water-blocking gel fills each tube, protecting the fibers from moisture, even in harsh underground environments. The loose tubes are securely sealed, creating an additional barrier against water, dust, and environmental damage. A central strength member forms the backbone of the cable, preventing stretching while supporting the delicate optical fibers. The protected fiber tubes are precisely stranded around the central core, balancing flexibility with exceptional structural strength. Water-blocking tape expands when exposed to moisture, preventing water from traveling along the length of the cable. High-strength aramid yarn reinforces the cable, allowing it to withstand powerful pulling forces during installation. An aluminum barrier provides additional protection against moisture, while improving the cable's long-term durability. For underground and industrial applications, corrugated steel armor protects the cable from crushing forces and physical damage. A rugged outer jacket is extruded around the cable. It shields every layer from moisture and abrasion. After cooling, precision laser instruments confirm the cable's diameter, ensuring every meter meets exact engineering specifications. The finished cable receives permanent identification markings, including specifications, meter counts, and traceable manufacturing information. A high-voltage spark test instantly detects tiny imperfections in the outer jacket before the cable leaves production. The cable is stretched under controlled tension. This verifies it can withstand the forces experienced. These forces occur during installation. Repeated bending tests confirm that the cable maintains signal quality, even when routed through tight spaces. Compression testing ensures the cable can resist crushing forces without damaging the delicate optical fibers inside. Waterproof testing verifies that moisture cannot penetrate the cable, even in harsh underground and outdoor environments. Laser-based testing measures optical attenuation, ensuring the fiber transmits light with extremely low signal loss. An optical time domain reflectometer checks every fiber for microscopic defects and confirms consistent performance over long distances. Before connectors are installed, the protective coatings are removed, and each fiber is precisely cleaved for a perfect optical connection. High-precision connectors are mounted to the fiber, creating secure interfaces for high-speed communication networks. Optical-grade epoxy permanently secures the fiber inside the connector, maintaining perfect alignment. Each connector is polished to a mirror finish, minimizing signal reflections and maximizing transmission efficiency.
High-powered microscopes inspect every fiber end face to ensure it is perfectly clean and free from microscopic defects.
Comprehensive optical testing confirms the finished cable delivers maximum performance across all supported transmission wavelengths. Only after passing every mechanical and optical inspection does the cable receive final approval for shipment. The completed cable is automatically wound onto precision reels, ensuring smooth deployment during transportation and installation. Automated cutting systems measure every meter with exceptional accuracy, preparing each cable for its final application. Each cable coil is securely wrapped. This protects it from dust, moisture, and mechanical damage during handling. Every reel receives a unique barcode and product label, allowing complete traceability throughout its service life. A final inspection confirms the cable's appearance. It checks identification markings and overall manufacturing quality before packaging. The cable reels are packaged in reinforced containers designed to withstand long-distance transportation and storage. Robotic palletizing systems organize finished products efficiently, preparing large shipments for worldwide distribution. Autonomous warehouse robots move finished products with remarkable speed and precision, while minimizing handling damage. Before shipping, every pallet is electronically verified to ensure complete order accuracy and full product traceability. The finished cables are loaded into shipping containers, ready to support communication networks across the globe. By sea, rail, and road, these cables travel thousands of kilometers before reaching telecommunications projects worldwide. Once delivered, the cables are installed beneath cities, across highways, and inside data centers to connect millions of people. Inside every optical fiber, pulses of light carry enormous amounts of information at nearly the speed of light. From purified quartz sand to precision-engineered communication technology, every layer is designed for unmatched speed, reliability, and durability. What begins as quartz sand becomes the backbone of the digital world. Through precision engineering, thanks for watching, and join us for another journey inside